So we are in Unit 6 and Section 2 deals with teaching bearings. Teaching bearings. At the end of this session, you should be able to describe the steps you will take the high school student through to solve problems on bearing of one point from another. You want to guide the student to interpret bearing as direction of one point from another. For example, in finding the bearing of a point A from O, we can use the four cardinal directions, that's the north, south, east, and west. So when you look at figure 1, we are using this one for some explanation. We refer to the turn of 60 degrees from the north towards the east as bearing of north, 60 degrees east. A away from O. A from O is going to be north, 60 degrees east. The nearest S direction to this particular vector is east. So we say north, 60 degrees east. Similarly, from B from O is going to be stated as south, 25 degrees west. South, 25 degrees west. Again, C from O is going to be north, 23 degrees west. North, 23 degrees west. So one thing that we have to remember is that, or keep in mind, is that bearings are always measured from the north or south pole, never from the west or east. So introduce students to the alternative way of giving bearing or direction. That is by reckoning north to be 0 and measuring angles from the north in a clockwise direction. In this method, north is taken as direction of reference and the angle is given in 3 digits. For example, if you measure and you have 8, you need to write it as 008, 3 digits. If you have 36, you need to write it as 036. And we know that bearings are always from the north pole. In this system, east is written as 90 degrees, south is 180 degrees, west is 270 degrees. Yes. The bearings considered earlier in Fig 1 and 60 degrees, north 60 degrees east and south 25 degrees west may also be written as 060 degrees and 205 degrees respectively. Similarly, north 23 degrees west is the same as 337 degrees. Now let's take another look at another diagram. We have 2 diagrams again, and figure 2 and figure 3. And this is what we call reverse bearing or back bearing. So suppose you are told to find the bearing of a point A from a point O, and that bearing gave us 60 as shown in figure 2. We can now guide our students to deduce the reverse bearing, that is the bearing of O from A. Initially we had A from O. Now we want O rather from A. So we are erecting another pole, another cardinal point at A. The north, south, east, and west at A. So that one can give us our back bearing or our reverse reverse bearing. So in this case, whereas that from A away from O we are 60. So if this part is 60, down here will also be 60. We call them the alternate angles. Here this part will also be 60. So and we are saying bearing are always from the North Pole. So from the North Pole we have 180, then we add another 60 to it, and that's going to give us 240. So our bearing of our bearing of O from A is going to give us 240 degrees. Similarly, in figure 3, we can also deduce the bearing of B from O, and that is going to give us 115 degrees. So if B from O is 115 degrees, then the bearing of O from B is 180 degrees plus 115 degrees. That will give us 295 degrees. So look at the figure 3 and use that one to justify this. So you can give your students more similar problems to solve and conclude that if the bearing of a point P from O is S degrees, then the bearing of O from P, that is the reverse bearing or the back bearing, is given by adding 180 to the angle we had initially we had S. So when you add 180 to that S, you get the back bearing, and this should be when your angle is between 0 and 180. The angle that you got, the S there, it should be between 0 and 180 degrees. If it's more than 180 degrees, there's another approach. Distance bearing form. To guide your students to represent bearing in distance bearing form, first explain to them, for example, what a journey along a particular bearing has. That a journey along a particular bearing has distance and direction, and hence it can be represented as R, that's the distance, and theta, that's the direction, where R kilogram is the distance and theta is the bearing. So this is what we are talking about. So the R is the distance and the theta here is the direction that we are moving in. Yeah, suppose the easterly and the northerly component of the journey is S and Y respectively. We can guide our students to apply the Pythagorean theory to find the length of the journey, which forms the hypotenuse of the resulting right angle triangle. That is, the length of the journey, r kilometers, is given by square root of s squared plus y squared. If theta is the bearing of the journey, then tan theta, which is equal to s over y, that's opposite over adjacent, which gives theta to be tan inverse of s over y. That will give us our direction. So if we want that direction, we are going to use the theta to be equal to tan inverse of s over y. So we have an example of a question. Suppose a car travels 6 kilometers east, then 8 kilometers north. Find the length and direction of the car from the starting point. So our solution is here. We can guide our students to represent the information on the diagram as shown. This is the direction. Suppose the final destination of the car is from point P and the bearing of P from O is theta. The journey can be represented as. So if you want the length, we can use the Pythagorean theory here. That's the R to be equal to square root of 6 squared plus 8 squared, given that R to be equal to square root of 36 plus 64. That's going to give us square root of 100, and our R will be 10. Now, if you want to find our angle, that's the direction, we are now going to use theta to be equal to tan inverse of 6/8. Tan inverse of our opposite. Here our opposite will be 6. Our adjacent will be 8. So tan inverse of that's going to give us 37 degrees. So therefore the car traveled 10 kilometers on the bearing of 037 degrees. That's the distance and direction form of a vector. This is the end of this session, and at the end of this session we learn about the steps one will go through to solve problems on bearing.